Thank you. I'm presenting myself again, Karina Poulain. I'm scientific designer for NASA's Ocean Ecology Lab. I know that's a title that might sound a little peculiar. It's a title I invented myself for my own job. So, basically, I have a background in ocean science. I have a PhD in remote sensing. My short story is I was very sad as a postdoc doing just science, and I never could help myself spending too much time on my PowerPoint slides, on my figures. That was always something I couldn't help but doing, even if I was a little bit embarrassed of doing that. And then one day I saw a job offer for someone who was a plankton scientist and knew about graphic design, and it felt like it was written for me. So I'm telling my little story like this because I know some of you might have non-linear paths or be interested in things that you think you're not supposed to, but it can end up in you getting a job at NASA. So yeah. Today I'm going to tell you about some visualizations that you can do with PACE. Obviously, it's just an overview. There's so many data sets that we have now. I'm not going to show you all of them, but hopefully this is going to give you tools that you'll be able to use for your visualizations. And first, I'm going to go quickly over our website. In a nutshell. I'll go over our website just so that you know when you're back home and you forget about what you saw here, you can find the information again, because it can be an overwhelming website, and we have the Help Hub to help you. So I'm just going to walk you through this pretty quickly. And yeah, Earth Data Forum also, and then we'll create visualizations. Okay, so to visualize space data, you need to know where to find it. So if you forget what Anna told you today, you can go on the PACE website and data, and you have the access to PACE data page. I have used QR codes liberally here, you can access those pages easily. So you'll find all the information that Anna gave you. You have also the data products table that Jeremy told you about in that same tab with data. So here you can find not only which data products are available, but also on the right column you have the ATBDs, which are the technical documents that come with each data product that tell you, you have the paper that was published about it and all the technical information about it. So that's where you find it, and you have also a point of contact for each data product. So if you have any advanced question that you cannot find the information for, you can contact the people who actually worked on the data set. And then there's the What You Should Know About PACE Data page that Jeremy showed. So there you'll find some basic information about the mission that you already know about, so I won't repeat that. And as Jeremy showed, you have the problems that can happen sometimes with there's some bands that either you might want to avoid using or you want to just be careful. So if you hover over that graph, you'll find the information for those bands. So you're welcome to use that. And there's some issues that are affecting all bands, and this will be updated very soon when we have the new reprocessing data, so this will change, but that's where you can find the information. And you have also the events, if there's a wild cosmic ray that affects the satellite, there might be a little period where there's no data, and if that's a period you're interested in, you might want to go check if there was a problem like that with your instrument that you're interested in. So it's the same, you can over the different bands and select the dates that you're looking at. And if you're working with the SWIR bands, there's some pixels that are missing on the side that just gives you more information about that. So this is quickly what you can find on the website, and you can access the Help Hub through the PACE website. So Help Hub, there's a lot of tutorials. Of course, for this week, you'll want most of the tutorials from the Hack Week website, but there's the tutorials from last year. For example, I gave a visualization notebook last year that was more about true color images. If that's something you're interested in, I'm not going to cover it today, but you can find it there. There's some other trainings that we gave with RSET. There's videos, if that's how you learn. So feel free to explore that. There's a ton of resources. We're always adding stuff there, and we'll be adding the tutorials from this week later. And there's some CDAS tutorials too, if that's something that you use. And we're open to ideas. If you're feeling like something is missing there that you would find useful, please tell us. And there's always the Earth Data Forum. I know it can be intimidating to post there because it's public, but really don't be shy. Trust me, if you have a question about something that doesn't work, there's a really high chance that it's the same even for us. And you'll be speaking directly to the programmers who are working on the tools. They're the best people to answer your questions, and your questions will be available for other people. Yeah, it's going to be a useful thing that you post there. So I understand the fact that it's a bit intimidating, but please go beyond that and don't be shy to communicate with us on the Earth Data Forum if you have questions after you're done with here, because here obviously there's a ton of people to help you, though, yeah, but when you're back home, yeah. So any questions before we go to the notebook? All right. Okay, so we're going to download it from the website. Here. So I'm going back on the website. Save link. Yes. Which is this one? Okay. I forgot which one. Open. No, not this. I normally drag it and drop it, but this is not my upload button. Oh, here. Okay, thank you. Yeah, it should be. Yeah, it should work with 14. Yeah, hopefully. Okay. Everyone has their notebook open. Yeah. Yeah, thumbs up. If you want. Yeah. Okay. Thank you. So. Yeah, I don't know why I wrote 4, but it should be 14 there. I'm sorry. So, yes?
Do you want us to restart the kernel before we start your notebook?
I don't think it should be necessary. No. Yeah, thank you. But no, I think it should work. Okay, so in this notebook, I'm going to show you first how to do a really quick global map from OCI data. You've seen it a little bit with Anna, of course. I'm going to show how to clean up the OCI data set for visualizing, how to create a quick plot for transect at a specific longitude, how to interpolate your data for visualization, how to create a multivariable RGB map with multiple data sets, and how to plot a timeline for different types of plankton, as an example, for a specific region of interest. So we're going to go through this. So here the libraries, we're using CartoPy, CCRS, because we're going to make maps, H5NetCDF. We're going to use PyInterp, which is the library that I use for interpolating. There are others. So this is an example. Seaborn, that's a library that does pretty graphs. And then the other libraries are some of the regular ones you might be used to for Python. So I'm going to import this, do the login. So you shouldn't have to enter your password again if you run Anna's notebook. Well, now we're going to search for data. For a time span, we're looking at the month of July for this. And we're going to make a map that has both some ocean data and land data on it. Yeah. I knew Sky would be happy. And we are, so for the Moana dataset, Moana first is an algorithm that's new with PACE. That one gives us different plankton types. We have 3 plankton types. We have 2 cyanobacteria, Synechococcus, Procolococcus, and we have pico-eukaryotes. So we have those abundances in the Atlantic. So it's something we're really excited about. For now, those products are only available in daily in the level 3 mapped. So I'm interested in looking at the month of July, but I'll just download all the daily data for that. But the land product that we're looking at is, as Sky showed you a little bit, with that beautiful map that changes with the seasons. So we have some carotenoids, anthocyanins, and chlorophyll indices that we're going to look at, and that is available in monthly. So that one will download the monthly data. Well, not download, I'm sorry, we'll access in the cloud and stream. So we can see here the granules that we have, 30 for Moana. And then this is what the data set looks like. So we have our level 3 mapped. So the latitude and longitudes are there and the coordinates. We have our multiple dates because we did the open multiple file data set function of Xarray. And we combined with the dates, like you've seen with Anna. So you see your different products here in the variables and the famous palette that I will not be using today, but feel free to use it if that's what you want to do. And then we have the land data set we're going to look at. We have only one file. And that one has a lot of different indices. I'm going to use 3, the ones that I told you about today. But yeah, there's multiple pigment indices in the LandVI suite. So we're going to make the quickest, easiest map you can do. You just have your dataset name, variable name. This is because we have multiple files, we're just selecting one, and dot plot, dot image show. Okay, this doesn't look very good. This is because we have outliers in that data set. So we're looking at Procolococcus. The cells per mil, you can see that it can go like really high. So a quick way to remove outliers with matplotlib is to do robust equals true here. And so now, okay, much better. We are able to see our data set. We can look at it quickly with the land. this one, yeah, looks good. It's overland. Everything looks right. We can continue. Now, yeah, the robust equals true is nice for a quick plot, but you might want to clean up your data set and look at, remove the outliers that are there. And one good thing is that in the attributes, you can find some valid min and max values. So if you look at Xarray, you can explore your data set a little bit with these buttons. This, I think, is, well, maybe I need to, yeah, this is more in the size and computing interest values, and this is, you have valid min and max values, the units, you have the long name, you can have the publication that was used as a reference, so you can really have more information on the data like that. We are going to use those valid min and max to clean up our data set, to remove our outliers here. So we're going to do that.
Karina?
Yes.
We have a question.
Oh, yeah, sorry.
Yeah, just a quick question about robust.
Yeah.
How does it distinguish between outlier and normal data?
I don't know exactly what's their formula for that. It's, yeah, I don't know, there's, Jan is, oh yeah, you're there. Do you know what's the?
I don't know what they use. I don't know what they use for the robust thing in Matplotlib, but I can promise you that it is geared towards optimizing for visualization, not for doing sort of like a statistical outlier analysis.
Yeah.
So I wouldn't think of using that as something you would be doing to like purposely eliminate robust, I mean, make robust data sets for analysis. It's for making nice looking images.
Second and 98th percentiles of the data to compute the color limits.
Thank
That's
you.
what robust does. So all the data. Google.
Thank you.
Does that make sense?
Thank you. So yeah, it's a quick way, but yeah, with using the valid min and max that have been put there by the creators of the algorithm, I think is a good thing to know. So this is what we're doing here. So we have both our data sets that we're clipping with the yeah, with the clip function with our values, and then we are going to remove the variables we're not using, like the palette. And in the land data set, there's a bunch of it I'm not using in this, so I'm just removing them like this with drop variables. Everyone's following so far? Yeah. Oh, you're getting an error? Okay. Okay, thank you. Now, since I got the data for the whole month of July, because we had only the daily data, I'm going to average here. And I put the average there in case you were selecting more dates for the land data set, but you probably won't need it there. And now we can plot the data for what I call a transect. So along a specific longitude, we are going to use a data set that select along our longitude with the nearest method to select the pixels that are the nearest to the longitude that we have. And then we're going to just plot the values of Synechococcus moana along that longitude with the latitudes and y. So what we see here is for that transect, we are seeing the values in the, well, it's cells per mil here, and we're seeing that, for example, Synechococcus is more in the higher latitudes in the month of July. So that's a really quick way to check that out. And now you can see there's some missing data here. So in my job, since my job is to make pretty images, I want to interpolate the data to just basically fill the holes and make it pretty. But in the case of science, of course, there's a philosophical question there when you interpolate. It's not just a magical creation of data. You want to think about why you're doing interpolation if you're doing it, if it affects your statistics. Yeah, just keep that in mind. So also the algorithm that you'll use for interpolation affects the results. So just keep that in mind. And in this notebook, I put it as a completely optional step. So if you don't want to do interpolation, you can just comment that whole thing and it will run fine. So that's just something that you might be interested in doing with me. So we'll see here, we'll see what our map looks like before the interpolation. So here we have the Synechococcus map. Obviously, it's just the Atlantic because it's Moana. Yeah, we have some clouds. It's the monthly average, but there's still some area hit. Oh, and then by clouds. Okay, sorry. And then we're choosing our margin, which is the amount of pixels that are going to be interpolated around the holes. So here we're just doing 1 pixel. The more you do, the less definition you have in your image. So that's a trade that you need to do. And then we need to put the data on the grid before interpolating. So this is just what this step is. It might take a few seconds. And then we interpolate it, and we have to do a transpose to have the data set back in its shape. So that's what this step is. And then we can plot it and see that now there are less holes in the data, but it did not fill everything because we only had 1 pixel. But yeah, that's the idea of the interpolation here. And we're going to do it more quickly for the land. Since you've seen all the steps, I put them all in the same here. And yeah, we're not graphing it at this step. Then we are going to make a RGB map with our 3 factors. So for that, we're using the red, green, and blue colors together to represent our 3 factors. But because, for example, the different species of plankton have very different concentrations, if you don't normalize your data set, you're just going to see Prochlorococcus everywhere because it's really dominating in numbers of cells. But if we're normalizing, we'll be able to see relatively the differences between each. So that's why we're doing that. With the land data set, because they're indices, it might be unnecessary to do it, but we'll still have it like that. And then we'll use image show to have our RGB. Here I'm selecting in order what I want as red, green, and blue. So this is a matter of taste. I do like to have Synechococcus in red because it's the cells are a little bit red. When you grow them in cultures, you have a little pink culture. Yeah, same with the carotenoids are red too, and chlorophyll green. So yeah, but that's personal taste. But that's how you choose what's going to appear in red, green, and blue. What's going on here? Oh, I'm not. Okay. And then we're going to make our figure. So here I went a little fancy with an orthographic projection. I'm choosing also some colors for the background for the ocean and for the land. I'm choosing a Z order for the different layers. So that's something, sometimes when you plot something with Cartopy with multiple layers and you're not seeing what you're expecting to see, it can be just a matter of that. So the higher the order, the higher the layer on your plot. Then we're going to just have our data sets here. And the patch set alpha is to remove the background when you export as a PNG. I do like my transparent backgrounds. So yeah, that's what we have here. Once it's done doing its thing, we should see it. Yeah. Does everyone have their globe? Thumbs up? Yeah, okay. Yeah, so we see both the land and the ocean data sets together in this. And I included, that one doesn't run like this, but if you want to export a PNG, that's the thing you can use. So in the Jupyter Notebook, I put it as a raw, so that the raw cells don't run. If you want to run it, just change it to code, and then it will actually export. Just a little tip. So I'll leave it as raw. And then if you want more of a classic map style, I give you the code for that here. That has grid lines. Oh no, I'm sorry, that's the legend first. Oh yeah, and this is, yeah, I was shamelessly inspired by the notebook that Ryan and Eli have worked on for their workshop. And there's a link here. I really encourage you to click on that link and explore that whole set of trainings. There's so many awesome tutorials there for place data. So yeah, please check that out. And yeah, Ryan and Eli made that, and it's awesome. So shamelessly inspired by them, I made a little ternary legend, a little code to make that legend here for that map. And it is something that was done. I'm not ashamed to say with ChatGPT because you know. Like, there's no way I'm not the type of coder who would just know how to do that myself. And I think, you know, I encourage you, if there's something a bit crazy like that you have no way to know, don't be afraid. Don't be shy to use ChatGPT for stuff like that. Of course, it's not perfect. Of course, you know, it took many tries before it did exactly what I wanted to do. You don't follow it blindly. But it's a great tool to explore things. And yeah, don't be shy. So yeah. And then here we have the more classic map with the grid lines. Yeah, and the plat carré projection. And you can choose, you know, with that code, you can adapt all the style from your grid lines. So feel free to reuse that code as you wish. Now we're going to plot a timeline of the plankton types for a specific region of interest. So we're going to get the data for a whole year because we're in the cloud and we're crazy. And we're going to do the 0.1 degrees because we're not too crazy. But and then here, this is a little code to have the dates and the attributes so that we can see it on our graph. Have it in the right order. And okay, so we're opening our data sets. It's very quick. Okay, so it's normal that it takes a minute. So we're going to combine the multiple data sets with the nested method and the dates. So we're going to have one data set with our whole year in Xarray. Any questions while we're waiting?
After you're done, I think you should address.
There's an error that multiple people are getting that we need to address when we're done. But
Okay.
it's the PyInterp that multiple people are getting errors about.
Oh,
So we just
okay.
need to troubleshoot that for. Okay.
Okay.
Yeah.
Okay. Thank you. Okay, so the data set is open now, so we can see our coordinates with lat, long, and the dates, and our 3 plankton types. Palette is there. I didn't clean it up there, but I will. So here we're doing the steps I showed you before, but faster. So we're removing the outliers, removing the palette. And then we're averaging and normalizing our data set like we saw before. And so here we'll select a region of interest. So we're going to select with our latitude and longitude. And I'm the type of person who always gets them mixed up, so I had a little code made so that it doesn't cause any problems here. So yeah, this is an optional thing, of course, but I thought maybe some other people have a weird brain like me, so I'm sharing it with people. And then we're going to plot our Moana data set and our region of interest together, so we can choose a place where there's a lot of variety in the different types of plankton, so we'll see. Yeah, so basically the new part here is that we're adding that little rectangle for the region that we selected before. Shouldn't be too long. The suspense. We can see the cell is running with that little asterisk here. It's another way to see it. This was, yeah, I had it here. Where was it? 346. Okay. But it shouldn't be that long. Well, I mean, this is a normal delay. We'll see it soon. Yeah. Yeah, here we go. Yeah, so we're seeing, you know, we're able to select a place where there's a good mixture of species here because we wanted an interesting place to look at here. So we're now going to select the data just for that little square there. So we're going to use the dataset.select and slice with the coordinates that we have chosen, which has now reduced our dataset size a lot. And we can plot like a quick timeline for our data set. So we're going to just do the mean for the square. And then we're going to plot it. So in the plot, we have here, this is not I think the standard way to necessarily style a graphic, but I do like to have the style like this in front, so you can change parameters and it changes for your whole graph. So you can just in one place change your marker size, or in one place change your color. Well, not the color because you want it, but you have the color palette here, so that will create the different. I'm sorry, this I shouldn't have. Okay, yeah. So yeah, you can have with Seaborn a color palette here, and you choose the number of variables you're looking at, and it will make a pretty color palette for you. And then you can have a different style for your graphic too with Seaborn. So look at their documentation to see the different styles you can choose from. Yeah, marker shape here, marker size, and line width I changed first. But you can, of course, adapt it to every single of your graphs. Here we're looking at the different species, and we have two that are comparable in terms of cell numbers, and one Procolococcus that is completely on another scale. So we're doing 2 axes for the Y. So here we're adding a Y-axis. So it's a bit of a crazy code. I don't expect you to understand it as I'm talking about it right now, but you can reuse this. That's the aim of this, is that you can just go back and reuse this in what you're doing. So this is pretty noisy. This doesn't look great, but you can start to see some maybe seasonal trends here. So if you want to see something more clearly, we're going to do monthly averages, which are really easy to make with the group by method. And we're going to group by month, and we're going to do a mean of that. And so we're going to do our same plot, and now that makes sense. Now we have more, we can see that, well, obviously we cannot compare Procolococcus with the others, but Synechococcus and Pico-eukaryotes get more comparable concentrations around November that year, and yeah, and then there's more Synechococcus compared to Pico-eukaryotes for the summer. So yeah, it's just an example of that. And yes, in that code you have the fill between method for the error bar instead of error bars. So you have the error areas. Yeah, you're welcome to use that for any other graphs. And yeah, does anyone have questions? Yes.
It's not a question, but a comment.
Yes.
So if you look down at the bottom, you see the memory. And I want to highlight that only 3.4 gigabytes of RAM were used for processing years of data. And how did that work? So what's happening under the hood for you is that when you saw that X-ray and it said a year of data, it didn't actually load the data into memory. It just loaded the metadata. And then there was the step where it's, oh, sorry. So it didn't load the data into memory. It loaded the metadata. And then before you went to the step where you're going to really have to load data into memory, so that mean, before you take the mean, you have that step that says, hey, subset it. And now X-ray knows that you want a subset. And then when you call the function that gets the mean and says, it's not just mean, it's mean and compute or mean and plot, then it's got to get the data. What's happening under the hood is it figures out this is the data I need, and it will only go grab the data you need. And this was a small box. So it didn't grab all the data. This is all happening for you. This is one of the really wonderful things that have happened with the community of earth scientists who figured out how to do this thing that was just done. I mean, it looks so easy now. It's not easy. There's a lot of things happening under the hood to make it easy and to use 3.4 gigabytes of RAM to do it.
Yeah, thank you. That's a really great point, Eli.
Yeah.
Any other questions?
Did anybody get through the post? Was all exactly? Like, you can. It's a
Yeah.
place.
There's a lot of information on this tutorial too, so if you're overwhelmed, that's okay.
Yeah.
It's to go back to like, so now re-enter and type and aids, spots that error line.
Definitely. And don't hesitate to ask me questions about this or anything else or any other of the mentors here. We're really happy. You know, you'll get a lot of information from our notebooks this week. Yeah, like Anna said, yeah, you can go back to it. You don't need to digest it all live. And yeah, feel free to ask us questions.
People with the PyInterp error, there's like four people over here. If you got the PyInterp error when you got it, I think it was resolved. Did you ever fix it? Okay, we will help, but more often than not, it's the image that you selected was a little wrong. So just make sure, maybe do it again and copy and paste exactly the line that you find on the website. Yeah.
Cool. Thank you, Karina.
Thank you.